Good afternoon, 7th grade. Today we are continuing with proportional reasoning, and today what we're going to concentrate on is similar figures. I told you that we would still use the tic-tac-toe strategy. So in your notebook, this is where I am. We're going to do some Cornell notes. So you can freeze this as you write it, but I'm going to move on ahead, and when you're ready, join us. Okay. You were given 2 sheets of paper. One was and I'm looking for it. Where is it? Okay, Ms. Kowalski. Where did it go? Oh, sorry. Okay, sorry. This yellow sheet right here. So when you're doing similar figures, the essential question that we're talking about is how do we find a missing side of an object when working with similar figures? But one thing that's important is understanding the proportions and how to set those up, okay? So one thing that we have to make sure is that the figures, so the question and definition of similar figures is that figures that have same shape but not necessarily same size. Okay. Now, for 2 figures that are similar, they are similar if the following conditions are true. Same shape. I'm going to kind of make this short instead of this long, drawn out. Corresponding angles are congruent. And what that means is, for example, in this right here. Sorry, the printer didn't pick that up. In other words, this angle is congruent to this angle. This angle is congruent to this angle. Okay, they're equal, and vice versa on that last one. And the last one is the ratios of the lengths of, and I'm going to abbreviate this, corresponding sides are equal, or rather proportional. Okay? And I left this out. The symbol for is similar to, we just do a little squiggly, just like that. Okay? All right, so in layman terms or in kid terms, student terms, we need to make sure that sides are proportional and that the angles are equal. Okay? All right, let's look at it in action. We want to know, are these 2 triangles, are they similar? Okay, so if we set up a proportion, what that means, first we need to identify the corresponding sides. So this corresponds to DE, and colored pencils are really, really helpful because sometimes this triangle might be turned, okay? And then that way you can identify. And then the last one, those 2 are corresponding, okay? So what this means, and if I did a tic-tac-toe, okay, and then my ratio, the green one, right, the ratios of the lengths of the corresponding sides. So that means that 6 is to 3, and if you notice, the same as when you read it in a word problem, as you read left to right or right to left, it goes top bottom in your tic-tac-toe, okay? The biggest thing is yes, we can move the numbers around a little bit because there's the relationship, for example, the ratio of 6 to 10 is also equal to 3 is to 5, okay? All right, and the red is 10 to 5. All right, and we know that when a proportion, when the sides are similar, the ratios of the lengths are equal, okay? And in a proportion, that means that 6 times 5 is 30. I could have reduced, yes. 10 times 3 is 30. So in a proportion, when the cross products are equal, the proportion is true. So we will say yes. Okay? All right, let's look at the next one. We're going to write a proportion. Now we're going to use a little bit of tic-tac-toe. So I need to find the corresponding sides. And what I'm going to do is find two sides that have two numbers. Okay? And if you notice that question mark, I'm going to go ahead and substitute a variable. Okay? So in a tic-tac-toe, first I'm going to pick the sides that have two numbers as my first ratio. And my second one, and the reason is you're going to get, this is your scale factor. Oh, sorry. I messed up. Scale, factor. Okay. I usually do new over old. That's something that we've always done, ladies. And the way to remember that is we always wear our new outfit over our old. And the reason is that will give you the scale factor if they say something, when they use it. We're going to talk about that later. But so when you set it up, let's pretend that I am going from a large one to a small one. So this is my new, and this is my old. Okay? So really, really important. If they don't, you just pick. One is new, one is old. And so if this is getting smaller, it is called a reduction. Okay? And we'll go over that later. But I just want you to learn how to set up the tic-tac-toe today, okay? All right, so our new green is 8. Our old green is 16. Our new red is 3. Our old red is X. And so now, back to our essential question, how do we find a missing side of an object when working with similar figures? And by using proportional reasoning, I can find that missing variable or that missing side, okay? Can I reduce here? Absolutely. We have a common factor of 8, greatest common factor. 8 divided by 8 is 1. 16 divided by 8 is 2. And so whenever you have a 1 across from your x, we can go ahead. I can't simplify anymore. So we're going to cross multiply. So 2 times 3 is equal to 1 times x, which is 6. Okay, and that's why I always say cross multiply and then divide by any number that is across from x. But remember that when it's 1, you don't even need to do that anymore. So the missing side is 6 inches. Okay? All right, I'd love to see you try the next one all by yourself. You can pause it and see if you get it right, or just keep on watching. Okay? Now, they gave us two variables. Okay, so we need to match them up with the corresponding sides. So this corresponds with the 4, and the 4 corresponds with the 8. And I'm going to do the last one. 3 corresponds with the y. Okay, so we need to find x and we need to find y. So I'm going to concentrate on my x first. Okay, so I'm going to write real small. Okay, that means that I have my x is green, and I'm always going to put my x on the right side. If you don't, it's not going to make that big of a deal. But the reason I say that is our scale factor has to be with two numbers, okay? I'm going to label it. I'm going to say this is my old, and this is my new. That means, if you notice, this was a reduction. Oh, I'm sorry. Yeah, it got smaller. And this one's going to get bigger. So it's going to be an enlargement. Pretty simple there. You're getting larger, right? All right, so I always put my new over my old. My new, which is going to be 8. New red is 8. My old red is 4. My new green is 4. My old green is X. Can I reduce? Absolutely. Why don't we just try it without reducing? Okay? So from here, that means that 4 times 4 is equal to 8 times x, right? And I have to divide by 8, which means 16 is equal to 8x. So I divide by 8, That's right. X is equal to 2. Okay? All right, let's set it up, and I'm going to hopefully have a little bit more room here. All right, so now what we're going to do is we're going to do Y. So again, I have my new over my old, and I'm going to pick my 2 numbers, which is going to give me red, and I'm going to use my purple color. The one mistake that everybody makes is setting it up incorrectly, and I promise you, if you make sure you have your 2 colors for your corresponding sides, new over old, you'll never go wrong. Okay, so my new red is 8. It's the same as before, or when we were solving for X. And my purple for the new is Y. There's my variable, and I have a 3. So can I reduce? I'm going to do 1 without reducing. And we ended up 4 times 4 and divide my answer by 8, the number across from X, which is what this equation was. Here, let's reduce. 8, they have a greatest common factor of 4. 4 divided by 4 is 1, which now is across from my variable, so I can't simplify anymore. 8 divided by 4 is 2. So now I'm going to cross multiply. 2 times 3 equals 1 times Y, basically 6. Okay, a lot of extra steps, but once you get used to it, it's pretty simple. Y equals 6. Okay? All right, we are going to hold on to this one until you come tomorrow. I just really want you to learn to identify the corresponding sides. Okay? So I'm not going to give you a whole drawn out, you don't have to do every single one of these, but here's what I want you to do. I want you to label corresponding sides and set up proportion. Okay? On the back, I want you to label corresponding sides and set up proportions, but I don't want you to solve all of them. I want you to solve, we're only going to do a few. I want you to solve 18. I want you to solve, let's see, number 23, 24, 17. And you notice that they're giving a bunch of numbers. Do you have to use each side? No. You pick 2 numbers that correspond, and 2 corresponding sides, and then the other 2. So these 2 might even be irrelevant, okay? And then on this side, I want you to do number 11, 9, and 10. All right, so recap. You're going to label the corresponding sides, which means color code, okay, and just set up the proportion. I only want you to solve 9, 10, 11 on one side, 17, 18, 23, and 24. So you only have to solve 7, but set them all up, okay? All right, I will see you tomorrow. Good luck.